So I'm here to talk about the project called the shortest routing path. Um, Here, as you can see, we're in Jupyter Notebooks, and here you can see the imports that I'm doing that are necessary to implement the Dijkstra algorithm. That is the one I'm implementing. So as you can see here, the graph variable are the labels of the nodes from the picture that Dr. Lu sent. Like I said before, I'm going to be implementing Dijkstra algorithm, and this algorithm, the time complexity of it is big O of the absolute value of v to the power of 2, and if we use a min priority queue, the time complexity will be big O of the absolute value of v plus the absolute value of e times the log of v. Here we are initializing some variables that we're going to use later. Here I'm creating the vertex dictionary, and in here I am using the pandas import to read from the Excel sheet the weights that were in the picture, and I'm transforming it into an array. Here are some functions that I defined. Here you can see the first function is length between u and v. You here get the length between two nodes. This one calculates the minimum vertex. This one gets the adjacent nodes. This one uses the get shortest path. And this one we use to call the Dijkstra algorithm. So what is happening here? Here I am passing the source node, in this case the ny, and I'm passing it to find the shortest path from the source to all the other nodes in the graph. This basically creates a shortest path tree from ny being the source node, and the values you see here are the initials and the weights. Now here the professor wanted us to calculate some specific shortest path, and this one calculates the shortest path between the New York and CA2. So here we're gonna calculate that, and this variable called previous has all the entries of the nodes to do the backtracking. We start as a destination, that's why you see here being printed the CA2, and with the help of the dictionary previous, we go back using the smallest weights till we reach our source. And since you can see here, you start at CA2, then you go to TX, then you go to DC, and then you get to NY. And the output you see, it's the source node and the weight to get from New York to CA2. And here I do the same thing, get the shortest path 3, but from WA. You can see the values here. Then I do the same thing to get the shortest path between WA to GA. Here I start at GA, then I go to PA, then I go to IL, then I go to WA, and the output is the source and the weight of it. Here I do the same thing, but for CA1 being the source, and here I do the same thing, getting the shortest path between CA1 and NJ. I start at NJ, then I go to MI, then I go to UT, then I go to CA1, and here you can see the source and the weight related to it.